the most complicated thing on a car, once we actually break it down to smaller parts, it won't seem so confusing. So here are the three sections of an engine. To the top left here, we have the engine bottom end, and this is referring to the block, crankshaft, connecting rods, pistons, and other related components. To the right of that, we have the engine top end, and this is referring to the cylinder heads, valves, camshaft, and other related components. To the bottom of that, we have the engine front end, and this operates the engine camshaft and sometimes the oil pump, distributor, and the engine sensors. If you have absolutely no idea what I just said, don't worry about it at all. We're going to get more into these different sections of an engine later on in different videos, and we'll be going into much more detail as well. But for right now, we're just going to start with the engine operation. Now, the engine provides the energy to propel or move the vehicle and operate the other systems within it. Usually fuel, such as gasoline or diesel, is burned within an engine's combustion chamber that causes expansion of the gases in the engine. This pressure is then converted into motion to then move the vehicle. So as we see right here, we have the combustion chamber, the piston, the connecting rod, and the crankshaft right here. So let's get into these specific things or ideas, the top dead center and the bottom dead center. The top dead center, or what is also referred to as TDC, this is the point where the piston is at the highest point in the cylinder, which would be right about there. Next to it, we have the bottom dead center, or what is also referred to as BDC. And this is when the piston slides down to the lowest point in the cylinder, which will be this right here. From this, we can now see a piston stroke. So this is the distance the piston slides up or down from top dead center to bottom dead center. So one 180-degree rotation equates to 1.5 of a turn for the crankshaft. So if we'd start right here at top dead center, the crankshaft would move all the way down here. And then vice versa for bottom dead center. It would start at the bottom, its way to the top. From this idea, we can then start to understand a four-stroke cycle. Now, the four-stroke cycle is required to have 4 piston strokes to complete one cycle, and for every 4 strokes, the engine produces 1 power stroke. And this continues over and over again, completing cycle after cycle until the engine is killed or the cycle is stopped. So, to start us off, we'll get into the intake stroke. Now, the intake stroke draws in an air-to-fuel mixture into the engine. The intake valve is open and the exhaust valve is closed. The piston slides down and forms a low-pressure area in the cylinder. So, air-fuel mixture comes in through here, through the open intake valve, into the combustion chamber as the piston is moving down. Next, we have the compression stroke, and this squeezes the mixture to top dead center to prepare for combustion. As the piston slides up with both valves closed, it pressurizes the fuel and air for a greater burn. As you can see right here, when the piston moves up, that air-fuel mixture is enclosed and squeezed because the intake valve and the exhaust valve are closed. Next, we have the power stroke, and this burns the air-fuel mixture and forces the piston back down to bottom dead center. The spark plug, which is kind of hard to see in this little diagram, it fires in a gasoline engine to be specific. It then ignites the mixture so that both valves are closed and it spins the crankshaft. So as the little burn happens, actually forces the piston down while everything is closed. And this is arguably the most important stroke in the entire four-stroke cycle just because of the power that comes from it. Next, we have the exhaust stroke, and this removes the burned gases from the exhaust combustion chamber, and it readies the cylinder for a fresh charge of air and fuel. The intake valve is closed and the exhaust valve is open. Exhaust is forced out of the exhaust port and into the exhaust system. So all the exhaust is moving out as the piston moves up. So while these individual strokes are consistent, a consistent cycle continues to go faster and faster depending on how fast the car is going. If you take a look in your car while you're driving, you will see the RPM gauge on your instrument panel, and this is actually gauging how fast the crankshaft is turning in revolutions. So with this little video, we can then see all these strokes together moving very fluidly, from the intake to the compression to the power stroke and to the exhaust stroke. It's pretty amazing.